kind of show y'all, we haven't, y'all know nested loops from Python pretty well? Nothing but thing for a nested loop. I mean, so that's a bad question. Do you know nested loops or you don't know nested loops?
You know.
You don't know it, okay. And if one person says that, probably there's like, 60% class agree with it. All right, so nested loops is just something we do in numerical methods where, it's kind of like lifting weights. So you might do like 3 sets of 8. So you do 8 repetitions and then you rest. And the next set you do 8 more repetitions and you rest. So it's just really when you think about doing it, it's a nested structure where you do this after this after this, then you rest, and then you repeat. And nested loops are going. What we're going to do is we're going to run this with a number of steps and make it a vector, and then we're going to look at the error at the end of the day. Okay. So what I'm going to do is I'm going to say. We'll make n steps be a vector, and I'm going to make it 100, and call it n step z. And I'll make it like 500, 1,000. So then I got a vector of those. Okay. And what I want to do is wrap my whole thing in terms of an analysis, which can now do that set of 8 reps. You can do it 3 times. All right, so I'm gonna make a, let's say K con stands for K converge is equal to 1, 2, 3. What I can do is I can just now grab n step is equal to n step z of K con. The whole thing should kind of run pretty nice right there. And then I'll say n the convergence. What I want to do is find an error at the end of the day. So let's say x error of K con is going to be equal to the absolute value of x Anybody have any questions on that statement right there? So what I'm doing is I'm running all those steps, and I'm going to hold on to the absolute value of how far the position is off. I'm going to do the same thing for the V error. Plot this anymore. So plot is I need to do a delta dt. Dt plot. That way I hold my delta t's and I hold my errors and I can kind of see how this thing's tracking. I want to plot dt plot. Let's just do that for right now, kind of see how it goes. Okay. Anybody have any questions on the nested loop structure?
Use your GT plot there.
Yeah, what I did is I just put a big loop outside and I just held onto the DTs. Okay. So we got an error right there. Let's actually, that one's so good. Let's see the shape of that curve. Still doing 3. Let's do 5. So we'll do like let me put in Grab something for this meeting. Thing in here. Little circles that kind of- Do like PV. Okay, so it kind of shows how our air behaves. If you all remember, the advertisement said that the air should be proportional to what? Where we truncate our Taylor series? Do we include the quadratic terms? So we should see something that has, we have to talk about it, but we should see a step error that's at least quadratic. Okay. That's a good stopping point. Why don't we pause right there? And we're going to see if we can beat this using some other numerical methods.
So back to the vibration dampening one.
That's what this one is.
Okay, is there a formula that you can use to determine what the critical dampening term would be without just randomly checking?
Yes.
Okay.
I just didn't want to do it. It's just easier just to check.
And so do you need time parameters of how quickly you want it dampened to do that, or how do you set
So
it?
the critical damping is like 3 to 4 MK,
Okay.
and C is less than that.